Welcome to this explainer. Today, we're diving straight into something that affects quite literally every single one of us, the architectures of scientific acceleration and planetary stewardship. You know the narrative. Scientific innovation isn't just some slow, steady march of progress anymore. It's an incredibly fast, rapidly accelerating system. And because of this sheer velocity, we've got to actively design the framework of our advancement. It's not just about surviving, it's about making sure we actually thrive.
Humanity is innovating faster than ever before, but we're simultaneously hitting the physical limits of our planet. Here's our roadmap for navigating from breakneck speed to a thriving future. We're going to look at the acceleration curve, examine innovation ecosystems, confront our planetary boundaries, and finally, look at designing our future.
Okay, let's dive into this first section, the acceleration curve and the compounding trajectory of discovery. So we all know technological development doesn't proceed linearly, right? It proceeds exponentially. The historical time gaps between massive technological shifts are shrinking right before our eyes. Think about it. We went from the Industrial Revolution in the 1800s, waited over a century for the information age in the 1990s, and then basically leaped right into the 2020s with AI-assisted discovery. The historian Derek J. de Solla Price actually documented this compounding growth by looking at scientific publications. Today, that lag between coming up with a hypothesis and validating it, it's practically vanishing. To put that into perspective, modern AI can now run thousands of chemical simulations in a matter of seconds. That is a pace that would take human scientists multiple lifetimes to pull off. Now, the intellectual bedrock of this curve was solidified by folks like Gordon Moore. You've probably heard of Moore's law, his observation that computational power doubles roughly every 2 years. Well, Ray Kurzweil took this even further with his law of accelerating returns, which essentially extends this compounding effect across all scientific domains. It's all driven by network effects. Basically, the more knowledge we accumulate, the more ways we can combine it, which creates this massive self-amplifying feedback loop. So why does this temporal compression matter to you right now? Well, because foundational shifts that once took centuries are now happening within decades, or even just a few years. And while this gives us an incredible amount of optimism for solving massive global challenges, it also puts us under immense pressure. We're frequently finding ourselves in this tricky spot where highly transformative technologies are deployed out into society way before we have the capacity to fully understand or regulate their long-term consequences. Moving on to Section 2, Innovation Ecosystems, or the Networked Mind. And this brilliantly illustrates how this acceleration is actually powered today. We've undergone a massive paradigm shift in how we create. The old model was that isolated genius, a lone inventor toiling away in a silo. But today, discoveries are driven by complex ecosystems. We're talking universities, private enterprises, government agencies, and financiers all working together. Creativity is no longer an isolated thing. It's deeply relational. These modern ecosystems totally thrive on what we call knowledge spillovers. This happens when discoveries in one domain unexpectedly benefit another. It's like how aerospace materials end up in your running shoes. Theorists like Joseph Schumpeter and Michael Porter hit the nail on the head when they identified that spatial concentrations of talent and capital are the true engines of this evolution. By co-locating expertise in places like Silicon Valley or Cambridge, setbacks just become shared learning opportunities, which fosters some truly incredible entrepreneurial resilience. So policymakers can optimize these ecosystems using network theory. They do this by identifying and strengthening the weak links between research and industry to accelerate ideas into reality faster. But we have to acknowledge that this raises a serious question. Concentrating massive resources into these specific geographic hubs creates real, valid concerns about equitable access. We have to continually step back and ask, who actually gets to participate in and ultimately benefit from these localized centers of innovation? That brings us to Section 3. Planetary boundaries, and the earthbound pivot. So the crucial point is that infinite acceleration is currently colliding head-on with the finite ecological boundaries of our planet. Earlier epochs prioritized growth at any cost, but we simply can no longer afford to do that. Foundational texts like Rachel Carson's Silent Spring and the Limits to Growth report really catalyzed a brand new awareness. They introduced systems-based analyses to environmental stress, and that forced a hard pivot toward managing our socio-ecological systems a lot more responsibly. The core scientific tool we use to manage this is the life cycle assessment, or LCA. Simply put, an LCA evaluates the total environmental impact of a product from the exact moment resources are extracted all the way to its final disposal. It often reveals some surprising things. For instance, the majority of a smartphone's carbon footprint happens before it even leaves the factory. By pairing these assessments with advanced climate modeling and satellite observation, we finally get the hard data necessary for responsible planetary stewardship.
We're actually seeing this applied in the real world right now through the principles of the circular economy. This model advocates for the regeneration of materials across three main steps: resource extraction, manufacturing and use, and finally, disposal and regeneration. And the technological impact of this is already evident all around us. We see it in the rapid transition to renewable energy systems, the rise of carbon-negative building materials, and innovations in sustainable agriculture, like precision and vertical farming.
Philosophically, this marks a profound transition for us as a species. We're moving from an anthropocentric worldview, where humans essentially act as the conquerors of nature, to an ecocentric worldview. In an ecocentric framework, human well-being is seen as completely inseparable from the health of the biosphere. They're one and the same. By embedding this kind of ecological literacy into our social norms and into international frameworks like the Paris Climate Agreement, we are slowly but surely evolving into active stewards of the Earth's complex interdependencies. Let's move to Section 4 and see how this all builds into designing our future, the path of intentionality.
So how do we actually integrate all this accelerating science and social design into proactive stewardship? Well, the process heavily relies on something called values-sensitive design. This is all about embedding human values, things like privacy, equity, and safety, directly into the engineering process from day one. Instead of treating these crucial elements as an afterthought, value-sensitive design uses systems thinking and computational simulations to anticipate unintended consequences well before a technology is ever deployed into the real world. Because ultimately, the goal here is to design a flourishing civilization. This integrated vision means we use technology to maximize human well-being while rigorously preserving our ecological resilience. We're going to leverage ubiquitous computation and global networks to coordinate planet-scale systems. Future breakthroughs are likely going to emerge from AI-assisted governance and predictive platforms that mitigate risks proactively. But the absolutely vital takeaway here is this: technology should be designed to enhance human creativity and agency rather than replace or constrain it. Which leaves us with this final, incredibly important question: will we merely survive the future, or will we intentionally design our destiny? By aligning our rapid scientific advancement with the strict imperatives of stewardship, we completely redefine what success looks like. It is no longer just about the accumulation of shiny new tools. It's about the cultivation of conditions under which human potential can thrive sustainably, in total harmony with our planet. Thank you so much for joining me for this explainer, and I hope this framework helps you see the accelerating world around us with some brand new clarity.